What if the water in your saliva could actually trigger enamel repair? Not toothpaste, not fluoride, just water doing its thing. Tooth enamel doesn't grow back. Once acids wear it down, from soda, citrus, or stomach acid, that loss is permanent. Most treatments focus on slowing damage, not rebuilding what's already gone. Instead of trying to regrow enamel directly, what if we could help minerals move into damaged enamel first, and only harden once they're in the right place? Ultra-small calcium phosphate clusters. These are the same minerals enamel is made of, but shrunk down to the nanoscale, so small they behave more like a liquid than a solid. To keep them stable, they used glycerol, a syrupy liquid that stops the particles from clumping too early. Here's the key idea. When these clusters meet water, like the water in saliva, the glycerol loosens its hold. That triggers the clusters to transform, harden, and lock into place inside the enamel. Water isn't repairing enamel by itself. It's acting as the switch that activates the repair material. They applied this liquid to enamel that had been gently damaged with acid. Within about 30 minutes, a dense mineral layer formed. They tested hardness, structure, and resistance to further acid. They also tested it under flowing conditions and in animals, not just static lab samples. The treated enamel recovered much of its mechanical strength. The new mineral layer bonded tightly, instead of just sitting on the surface. And it handled another acid challenge better than untreated enamel. This did not fully recreate natural enamel. The structure isn't identical, and this isn't ready for real patients yet. Most approaches try to coat enamel from the outside. This one lets minerals flow into damaged areas first, then harden in place. This isn't a miracle cure, but it's a smart materials idea. Use saliva's water as a trigger, not the treatment. Saliva, rinsing your mouth. Also saliva, I activate nanochemistry now. Do you think future dental treatments will rely more on smart materials like this, or stick mostly with fluoride?